So I just wanted to um, get something down to paper or on video or whatever about agent-based modelling. You'll have to excuse me because I've got a bit of a cold and I'm slipping a lemsip. So, agent-based modelling, click to add subtitle. So what is agent-based modelling? Well, it's a modelling technique, and there's kind of three things you need to kind of remember. The first one is that the model is made up of entities called agents that are all independent of each other and can interact with each other. And how they interact depends on what type of agent it is, and you can create your own rules to how they interact and give them all different properties, and the properties can change when they interact. The collection of these agents and the interactions between them and what happening is called a system. And the most important thing with agent-based modelling is that when we run the system, you can see patterns emerging out of the interactions of the agents. So at this small, like micro level, we have agents talking to each other and doing things, and then at kind of the massive macro level, you can see that these small interactions are having a bigger, larger effect on the system. So the easiest thing to try and get this across is probably to walk you through what it's like to build a very simple agent-based model. So the first thing you need in an agent-based model is what's called the environment or the patch. If you use NetLogo, it's called the patch, I think, which is the most popular agent-based modeling tool. So this is my very simple environment. It's just a field, and in this field, green squares represent grass, and brown squares represent mud. And so once you've got an environment, you need to add the agents. And so we've got two types of agents here. We've got these little sheep, which are called prey agents, and these little wolves, which are called predator agents. So these are going to have different rules. So the next thing we can do is to create a rule set. So the environment needs rules. So very simple. If grass is eaten by sheep, it turns into mud, and the grass grows back after a certain amount of time. So it's quite a simple rule there, that these green ones will turn brown if there's been a sheep on them, and after a while they'll turn green again, turn back into grass. The wolves themselves will chase the prey because they need the prey to eat for energy, and they can reproduce. So behind each of these agents is a little bit of code that says chase the sheep. If you get to the sheep, then eat it, which gives you high energy. And let's go back a bit. Sorry. And if you meet another predator agent, then you can reproduce. And the same for the prey. They've got similar but slightly different rules. So instead of eating other animals for energy, they get energy from the grass. They eat grass, and they can reproduce if they're near other sheep. And these don't chase anything; they just kind of walk around. So these rules are code in your agent-based model, and you can change them. They can be slightly different. Perhaps you want the prey to run away or whatever. And so when you run a model, this is what it might look like for one that we designed. And this is running in a tool called NetLogo. So and this is commonly what a model will look like in NetLogo. This bit here at the bottom, I don't know what I'm on about. Sorry, it's just the cold. So this bit here is your environment. You've got setup and go. These are buttons, and behind these buttons will be a bit of code. So clicking setup will create your environment, perhaps put up your predators and prey there, and then these are all the parameters that you can change in the model. So perhaps you want them to reproduce more often, then there's a little slider here that which I think is the percentage of chance that they'll reproduce when they get together. They've got other things like how fast they move, the growth rate of plants can change, and then what usually happens is there's a little play button, and you click play, and what's work? Doesn't matter if it doesn't. So yeah, I've clicked go on this model, and as you can see, there was a massive increase in predators at the bottom here, because there's loads in one area. But then, because they're all in one area, there wasn't enough sheep, so they died out. The sheep ended up living up here, where they kind of died out because the grass ran out. And that's the kind of thing you see when you're in a model. So that's kind of a very basic model of construct the virtual world, then we interacted through it, and then we saw some, I don't know what we saw. Let's just go to the next page. So this was the Predator Play game, which you can download. There was a model that already existed. The link was on the other page. What was interesting about this one, this is the description of the model, and what was interesting about it is actually some people could control the agents if they wanted to by like kind of dialing into the model. When you run that model, it gives you what it actually gives you is an option to run a server. Other people with the same model can connect and can control either the sheep or the prey. So it becomes like a game, and so this type of model's interesting because it's not really predicting the outcome of a scenario, because there's so many factors in predator prey kind of games. We're missing out any kind of human interaction, other things in the environment. Perhaps sheep are slower than wolves, perhaps they're faster than wolves. There's lots of variables that we didn't collect in that model. So it wasn't really predicting what was going to happen, but instead it was a great way of exploring population dynamics. Got some ideas to students who were participating in the model about population dynamics, and they can do different things that maybe aren't coded into the model. What happens if we try to do this with the predator for the play, or this, or and then they can, later on they can code that into the model if they wanted to go back and add those rules into the model. So that's quite interesting. This is some bullshit about the fact that models are not. They don't have to be like a physical environment. So in that last example, we had the predator-prey model, which is something that happens in a field. I could probably do added another one here. Let's edit this as I'm going along, eh? Another example over here. But these are some examples of models which aren't in a physical environment. So one that I played with is the skim model. The skim model tries to simulate the transfer of knowledge between different institutions and what in a knowledge network, an innovation network. And so in this example, agents aren't like just one thing, so they're not one person. They're in the skim model of firms or universities or consumers or suppliers. So the agents don't have to be like a thing. You can scale it up to make them like an agent could be a whole institution like they are in the skim model, or they could just be one thing. They could be a person. In the skim model, agents have to be innovative to survive, and that's like a variable, and different things change the variable. I didn't think it was very good as a way of trying to actually simulate how innovation is shared. I didn't really think it was a very good example of that. But what I did get from using that model was I understood how someone else thought the innovation might be shared. So the person that created that model, the skim model, it was kind of a great insight for me to work out how the people from Surrey thought innovation was shared between firms or universities or whatever. There's been some work done on supply chain modelling, which I think that's something that we're doing in Work Package 7. I said Work Package 7, but you've got no idea what Work Package 7 is. That's a project I'm working on. And then another example, which I've not looked up yet, will go here. Next page. And so the key themes that I take from edge-based modelling is you start it kind of has what's called a bottom-up approach, because you're modelling agents and you're not modelling kind of what you see at the top level of a system. You're modelling what's happening on the micro level. It's got what's called a bottom-up approach, so you're concentrating on what each individual agent does rather than what the output is of putting individuals together. And when the yeah, whatever bullshit. I need to change this page. Let me just write a message to myself to change this page. That's pretty much the same, isn't it? Might delete the last page. Yeah. So I haven't got this across already. That what I like about agent-based models, not DBM. What the fuck's DBM? Agent-based model. You know the whatever. Platforms, useful sites. Right, practice again in a minute.